There is a shape on the Giza Plateau that has outlasted every empire that has ever looked at it. Rome rose and fell in its shadow. So did the Ottomans, the Mamluks, the Ptolemies. It was already ancient when Cleopatra walked past it. And recently, someone decided to ask a modern artificial intelligence a very old question: who actually built this thing, and why does it still refuse to make complete sense? The question was simple on the surface. Who built the pyramids? But the way it was asked mattered. Instead of asking for the textbook answer, the person fed the AI system raw data, survey measurements, engineering tolerances, orientation figures, geological notes, and asked it to reason through the numbers without leaning on the assumption that the traditional story must be correct. No agenda, no hidden instruction to find something spooky. Just, look at the measurements and tell me what they actually support. What came back wasn't a name. It wasn't a new pharaoh, or a hidden inscription. It was a pattern of numbers that, when you sit with them, make the hair on your arms stand up a little. Because the machine didn't reject the mainstream explanation outright. It did something more interesting. It said the story we've been told explains a lot, but not everything. And the gap between a lot and everything is where this video lives. Before we go further, it's worth saying clearly, this isn't a case of secret evidence being hidden from the public. Everything discussed here comes from measurements and studies that are publicly available, gathered by actual archaeologists, surveyors, and engineers over the last century and a half. What's new here isn't the data. It's the way an AI system laid it side by side and asked us to explain the whole picture at once, instead of one piece at a time. So let's start with the story most of us grew up with, because it deserves to be told honestly before we start poking at it. The mainstream account says the Great Pyramid was built for the pharaoh Khufu around 2560 BCE, during Egypt's 4th dynasty, over a construction window of roughly 2 decades. It wasn't built by slaves dragged in chains, despite what old movies suggest. It was built by organized, rotating crews of laborious, skilled workers, seasonal farmers between Nile floods, bakers, brewers, medics, who lived in a purpose-built town at the base of the plateau. We know this because archaeologists actually found that town. They found bakeries capable of feeding thousands. They found cattle bones showing the workers ate well. They found skeletons with healed broken bones, meaning injured laborious were cared for, not discarded. They found workers' graffiti in red ochre naming their crews things like Friends of Khufu, proud nicknames scrawled on blocks never meant to be seen again once the casing stones went up. This is not a flimsy theory. It's the product of serious, rigorous fieldwork, and it explains an enormous amount: the manpower, the logistics, the food supply, the social organization required to run what was essentially a small nation dedicated to one construction project. What it explains less convincingly is the precision. And that's the thread the AI pulled on. Let's talk about the base of the pyramid first, because this is the least flashy number in the whole story, and honestly, the most quietly disturbing. The base of the Great Pyramid covers over 13 acres, roughly the footprint of 9 football fields squeezed together. And across that entire footprint, the leveling of the foundation varies by only about 2 centimeters, less than an inch. That's not pretty flat. That's flat to a tolerance that modern construction crews, using laser levels and satellite positioning, don't always bother matching, because buildings don't need to be that flat to stand for centuries. A tomb, whatever else you want to say about it, does not need to be level to a fraction of an inch across the length of several football fields. Nobody buried inside is going to notice a 2-degree tilt. So why is it that flat? The traditional toolkit available to Old Kingdom builders was, according to the archaeological record, limited to things like copper chisels, wooden mallets, plumb lines, and channels of water used to establish a level surface. That's a real and clever technique. Water finds its own level, and a network of trenches filled with water can absolutely help you check a surface. But holding that kind of precision consistently, across a surface that large, without any drift from wind, evaporation, temperature change, or simple human fatigue, is a genuinely hard engineering problem. It's not impossible. But it's the kind of outcome you'd expect to see fail constantly before you saw it succeed even once, let alone succeed at this scale on the first major monument of its kind. Then there's the orientation. The four sides of the Great Pyramid are aligned to true north, true south, true east, and true west with an accuracy that modern surveyors would be proud of, within a few arcminutes of true north, according to multiple independent surveys conducted over the last century. And here's the detail that makes this different from just they were good with compasses. True north isn't something a compass can give you. Magnetic north wanders. It drifts over centuries. True north is the fixed point in the sky around which the stars appear to rotate, the projection of Earth's actual rotational axis. To find it without modern instruments, you have to track stars across the night sky for an extended period, identify the point they circle around, and then transfer that invisible celestial point down into a physical line on the ground, and hold that line straight across a construction site the length of several city blocks. Ancient Egyptian astronomers almost certainly did this using a technique involving the observation of two circumpolar stars and bisecting the angle between their rising and setting points, a method scholars have proposed and tested with real historical plausibility. It's a genuinely elegant solution, and it shows real astronomical sophistication for the era. But it still leaves us with a monument oriented more precisely than most temples built thousands of years later for the explicit purpose of astronomical worship. Why put that much care into an alignment that no visitor, no priest, and no pharaoh could ever verify with the naked eye? Nobody standing at the base of the pyramid in 2560 BCE could tell the difference between aligned within 3 arcminutes and aligned within 3 degrees. That precision wasn't for an audience. Which raises an uncomfortable question: who was it for? Now let's get into the part of this that mathematicians have actually argued about for 2 centuries, because it's the strangest thread of all, and it's worth handling carefully. If you take the full perimeter of the pyramid's base and divide it by its original height, the height it had before the outer casing stones and capstone were stripped away by later builders looking for building material, you get a number that lands remarkably close to 2 times pi. Not exactly pi, and not a perfect match by any means, but close enough that it's been noticed, debated, and remeasured by researchers going back to the 1800s. There's a very reasonable, very mainstream explanation for this, and it's worth taking seriously instead of dismissing outright. Egyptian builders are believed to have measured horizontal ground distances using rolling drums or measuring cords, and measured vertical height using stacked cubit units. If you build using a wheel that rolls out distance, the geometry of a circle, meaning pi, sneaks into your proportions automatically, without the builders ever needing to know the concept of pi as an abstract idea. You get the relationship for free, as a side effect of the tool, not as a deliberate design choice. This is a genuinely elegant explanation, and for a single measurement, it's convincing. Where things get murkier is when you look at other proportions inside the structure, internal chamber dimensions, slope angles, and notice that a second irrational number, the golden ratio, roughly 1.618, shows up in several of them as well. The golden ratio doesn't sneak into your numbers the way pi might from a rolling drum. It has to be deliberately calculated using a specific mathematical relationship. It's not a byproduct of any known Old Kingdom measuring tool. And the earliest written description we have of the golden ratio, as a formal mathematical concept, comes from Greek geometers roughly 2,000 years after Khufu's pyramid was completed. To be fair to the skeptics here, and it's important to be fair, some researchers argue these later golden ratio matches are the result of people hunting for patterns in a large data set of measurements and finding what they were looking for, a phenomenon statisticians call apophenia, or more specifically the look elsewhere effect. With enough dimensions, enough slopes and ratios to compare, you will eventually find numbers that approximate something famous, purely by chance. That's a completely legitimate scientific objection, and it deserves to sit right next to the more dramatic claims, not underneath them. But the AI's analysis, when asked to weigh the probability, flagged that these ratios weren't appearing once in isolation, they were turning up at multiple, structurally unrelated points in the design. And the more independent places a pattern shows up, the harder it becomes to wave away as coincidence, even accounting for the look elsewhere effect. That doesn't prove intention. It doesn't prove the builders sat down and consciously encoded the golden ratio into the walls. But it does mean the "it's definitely nothing" explanation gets harder to hold onto the more data you add, not easier. Then there's the number that tends to end these conversations in stunned silence, the Earth-scale relationship. If you take the height of the pyramid and multiply it by 43,200, you land startlingly close to the polar radius of the Earth. Multiply the base perimeter by the same number, and you land close to the Earth's equatorial circumference. And 43,200 is not a random figure, it's exactly half the number of seconds in a full day, tied directly to how we divide time using the planet's rotation. Here's where honesty matters most. This is one of the most repeated claims in pyramid mystery content, and it's also one of the most heavily disputed by actual metrologists, people who study historical measurement systems for a living. Critics point out that if you're allowed to choose your multiplier after you already know the answer you want, you can make almost any two numbers relate to almost any other two numbers. That's not a small objection. It's the central weakness of numerology as a method, ancient or modern. Extraordinary claims about global measurement systems require the multiplier to be independently justified before you go looking for a match, not selected afterward because it happens to fit. And yet, and this is the part worth sitting with rather than resolving neatly, the fact that skeptics can explain away any single instance of this doesn't fully explain why so many independent measurements from this one structure keep clustering around meaningful numbers instead of scattering randomly. Maybe it's coincidence stacked on coincidence. Maybe it's the human mind's talent for finding shapes in the clouds. Or maybe there's something about how the structure was actually laid out that we don't fully understand yet. The honest answer, even from a system built to reason without bias, is that we don't currently have enough information to close this question completely in either direction. So what did the analysis actually conclude? Not that aliens built the pyramids. Not that a lost supercivilization, with satellite-grade tools, was secretly running Bronze Age Egypt. It concluded something quieter and, in some ways, more useful, that the standard explanation accounts for the labor, the logistics, and the motive, but does not yet fully account for the precision. That's not the same as saying the standard story is false. It's saying there's a gap between what we can prove about how the pyramid was organized and what we can prove about how it was measured with such extreme accuracy using only the tools the archaeological record has confirmed existed at the time. That gap leaves room for a few different possibilities, and reasonable, non-fringe researchers land in different places on them. Maybe Old Kingdom Egyptians had measuring and surveying techniques more advanced than what has survived in the written record, techniques passed down as craft knowledge rather than documented theory, the way skilled trades today often outperform what's written in a textbook. Maybe some of these numerical matches really are coincidences amplified by our own pattern-seeking brains, and the mystery shrinks the moment a better statistical analysis is run. Or maybe, as some researchers argue, we are simply underestimating just how good ancient astronomers and surveyors already were, since we've only recently developed the instruments precise enough to even measure their achievement accurately. What made this AI-driven pass through the data interesting wasn't a shocking new verdict. It was the refusal to pretend the two competing intuitions, the very human archaeological story of bakeries and healed bones and workers proud enough to write their names in red paint, and the still unexplained mathematical precision baked into the stone, cancel each other out. They don't. Both are true at the same time, and the tension between them is exactly why this monument still pulls people in more than 4,000 years later. There's one more layer to this worth walking through, because it's the part most videos on this topic skip entirely, the internal architecture. Deep inside the pyramid sits the king's chamber, roofed not by a single slab, but by a series of enormous granite beams, some estimated to weigh in the range of 25 to 80 tons apiece, stacked above one another in a configuration designed to redirect the crushing weight of millions of tons of stone above it away from the ceiling and out toward the surrounding walls. Engineers who have studied the design describe it as a genuinely sophisticated load-relieving system, the kind of structural thinking you'd expect from someone who understood, at least intuitively, how compressive stress travels through stone. And it worked. That ceiling has held for over 4,000 years without a structural failure, despite sitting under one of the heaviest static loads any man-made ceiling on Earth has ever been asked to bear. The mainstream explanation for this is that Old Kingdom engineers learned through generations of smaller pyramid projects, some of which famously failed, like the bent pyramid at Dashur, which shows visible signs of a mid-construction redesign after the original angle proved structurally unstable. That failure, ironically, is some of the best evidence we have that this was a human learning process rather than a technology handed down complete. It shows trial, error, and correction, which is exactly what you'd expect from a civilization refining its own methods, not one operating from some perfect inherited blueprint. If Old Kingdom builders had access to flawless pre-existing knowledge, it's a fair question why earlier pyramids nearby show cracking, collapse, and awkward mid-build corrections at all. That's an important counterweight to keep in mind. And yet the counterweight doesn't fully collapse the mystery either, because whatever lessons were learned from those earlier failures, they were learned astonishingly fast. The gap between the collapsing or leaning pyramids that came before Khufu's and the almost impossibly precise result at Giza is measured in mere decades, not centuries. Somewhere in that short window, whoever was directing these projects went from struggling with basic structural stability to producing what is still, by several measurable standards, one of the most precisely constructed large structures in human history. That compressed timeline is its own puzzle, separate from the leveling and the alignment and the ratios, and it deserves its own honest question mark rather than a tidy answer in either direction. It's also worth addressing directly one of the more sensational claims that tends to get bolted onto this topic online, the idea that the nearby Sphinx shows weathering patterns consistent with heavy rainfall in a period long before conventional Egyptian chronology begins, implying a civilization far older than the pharaohs carved it. This is a real academic debate, associated most prominently with geologist Robert Shark, who has argued the erosion patterns on the Sphinx enclosure look more like water weathering than wind and sand erosion. It's a serious argument made by a credentialed geologist, and it deserves to be represented accurately rather than dismissed as fringe nonsense. But it's also far from settled consensus. The majority of Egyptologists and geologists who have examined the same rock formations argue the weathering is consistent with known wet periods in Egypt's early history, well within a timeframe compatible with the traditional dynastic dating, and that alternative erosion mechanisms explain the pattern without requiring a rewrite of the entire chronology. The honest summary is that this remains a live, minority scientific dispute, not proof of a lost civilization, and it shouldn't be presented as though the debate has already been won by either side. So here's the actual question worth sitting with, and it's one you can answer without picking a side in a culture war about ancient aliens. Given everything we can verify, the tools, the labor force, the astronomy, the math, where do you think the honest edge of our current knowledge actually sits? Do you think future research will fully explain the precision using tools and methods we simply haven't reconstructed yet? Or do you think there's a real, still unsolved piece of this puzzle that no explanation has managed to close? Drop your take in the comments, and if you want the next video to look at a different ancient site through the same kind of unbiased, numbers-first lens, let me know. There's another location where a strikingly similar pattern has been reported, and it's worth putting to the same test.